Here's a little Frank Sinatra for you, New York, New York, in honor of the Yankees playoff run right now, up to 3-2 on the Astros if you're keeping score at home. This video is on quadratic equations. I forgot to put that slide in to remind you to take notes, I'm just realizing, but do it anyway. It's always a good habit. So, we're going to learn 5 different ways to solve a quadratic. First is not listed, I guess it's the 5th, and that's graphing. Alright, any equation, if you have a calculator, you can solve by graphing both sides, and we'll check our work with that. The first way is factoring. That's always look for that first, because it could be the quickest way to do it, but it doesn't always work. Extracting the roots, that works in certain situations. Completing the square and quadratic formula work every time, but can get a little complicated depending on the numbers, and will take more time than factoring if the quadratic is factorable. And right there's standard form. Just have the equation set equal to 0, and the coefficients in front of x squared is a, coefficient in front of x is b, and then the constant term is c. And the quadratic formula references those. So, that's all to start. Because again, I talked about graphing. Anytime you're asked to solve an equation, just graph both sides. So, first factoring. The reason why factoring and standard form are so important is 0, right? So for quadratic formula and factoring and completing the square, your first step is to get the equation in standard form. Get 0 on one side of the equation. The reason why you do that for factoring is because 0 is special. Any number times 0 is 0. So if you have it factored and it's set equal to 0, then any of those factors, any x values that make those 0, will make the entire polynomial 0. Thus, a solution to the equation, it would give you 0 equal to 0. Whereas, if it was something, if you set equal to like 1, for example, then if one factor equals a number, then the other factor would have to equal its reciprocal, which complicates things a lot more than just having one factor equal 0. So, let's use that. So solve by factoring. So like we just talked about, first we want to get this in standard form. So notice how I'm going to bring everything over to the right side so that I have a positive coefficient in front of x squared. You don't have to do that, but I always like to work with a positive coefficient for x squared. So, and it doesn't matter what side is equal to 0. So you add x squared to both sides, you get 3x squared. You combine like terms here with 6x is 10x, and you get 10x, so you subtract 10x on both sides. That gives you negative x minus 10x on the right side, so that's minus 11x. And then add 7 to both sides, and you get a 6 over on the right side. So now, I just paused that because I noticed something wasn't right. Right here, I didn't add negative 1 to 7. So this right here should be a 6. So now that's at equal to 0, we can factor that polynomial. So two numbers that multiply to 18 and add to negative 11, that would be negative 9 and negative 2. So we could break up that negative 11x as negative 9x and negative 2x, and then plus 6, set equal to 0. Now we could factor by grouping, so pull out a 3x, and you get that times x minus 3. Pull out a negative 2, and you get that times x minus 3 again. Factor one more time, and you get 3x minus 2 times x minus 3 is equal to 0. So that means if we set each factor equal to 0, 3x minus 2 and 3 minus x, so first I'll show you, set that equal to 0, add 2 divided by 3, you get x is equal to 2/3, and if you do it with this factor, you get x is equal to 3. So from this complicated equation in the beginning, if you were to plug in either 2/3 or 3 for x, it would make both sides equal. And we did that by factoring, setting one side equal to 0, and now either of those numbers make either 3x minus 2, 0, or 3, 0, and it doesn't matter what the other one equals. So, now let's check it. I'm going to open up my graphing calculator, and I'm going to graph both sides of the original equation. So on one side I'm going to graph 6x minus 7 minus x squared plus 4x. So I'm going to go to a new document, add graph. I'm just going to type that in. So it's I forgot what it was. 6x minus 7. And then minus x squared plus 4x. So minus x squared plus 4x on one side. And you get a parabola. The reason why it looks like a parabola is because of all these terms, 6x, negative 7, x squared, and 4. When x gets really large, so down one way of the x-axis or the other way, this term is going to get way bigger than the other three terms. And because there's a negative in front of it, like for example when x is 100, this term is going to be negative 100 squared, which is negative 1,000, or 10,000. And that added to 6 times 100, or negative 704, is still going to be a very big negative number. And that trend is just going to continue. And that's how this gets its parabola form. Now we've got to graph the other side, so we're going to hit tab. And we see it's 2x squared minus x minus 1. So 2x squared minus x minus 1. And now we see where they intersect. And you can tell it's right around 2/3 and 3. And to check for sure, you can analyze the graph, do the intersection tool, and use that to see that, alright, when x is equal to 0.66, which is 2/3, both of these equations, which are each side of the original equation, will equal each other. They'll both equal negative 7.8, so that's one solution. And then check the other one by finding the other intersection, and we know it's 3, so we know it should be somewhere between 2 and 4, somewhere around 3 on the x-axis, and you get 3, 14. So that means if you plug 3 into either side of this original equation, both sides will equal each other, specifically 14. That's what the y-coordinate is. Alright. Next is solving a quadratic by extracting the square root. So it's pretty much, if this only works if you have one variable being squared and no other variables with degree 1. And you can either isolate the variable that's being squared and take the square root of both sides, or set one side equal to 0 and factor it like a difference of two squares. So, for example, in 4x squared equals 12, we could divide by 4 and take the square root of both sides. Or you could just do factoring, bring the 12 over, and then factor out of 4, and you get x squared minus 3. And then now factoring using the difference of two squares, we get 4 times x minus root 3 times x plus root 3. So we could set each factor equal to 0. 4 equals 0, not possible, so because there's no variable there. But you set this equal to 0, you get x is equal to root 3. And you set that equal to 0, you get x is equal to negative root 3. So you get plus or minus root 3. Same thing with number 2. Number 2, we could just take the square root of both sides. We could have done that in the other equation. And we get x minus 3 is equal to, now here's the tricky part when you take the square root of both sides. You have to remember to add the plus or minus. Because this right here, let me change the color so you could see what I did. So I just took the square root of both sides. So this part right here, if it was equal to negative root 7, you square it, it would still become positive 7. Or if you had just root 7, you square it, it'd become positive 7. So both those versions work. So you add 3 to both sides, and you get x could be plus, x could equal 3 plus root 7, or x could equal 3 minus root 7. So that's extracting the root. Just isolating x, taking the square root, putting the plus or minuses, or getting equal to 0 and factoring using difference of two squares. Now this is something that we're going to do in class, but if you expand all these binomials out, there's going to be a pattern. And what they all have in common is that they're all perfect square trinomials, meaning they come from squaring a binomial, like x plus 1 squared, x minus 2 squared, x plus 3 squared. Unlike if you factored something and it was like x plus 2 times x minus 3. Those are different factors. It's not a perfect square. These are. And when you do multiply them out, you'll notice that each one is in this form, where if you took this x plus b over 2 squared, which represents the binomial being squared, this middle coefficient, b, would be this times 2, and then half of that squared would be the last term. Alright, and again, we'll do that in class and you'll see that pattern, but for now you just gotta trust me. So using that information that every perfect square trinomial is in this form, x plus b over 2 squared, we can use that to factor and to solve and to what's called complete the square. So our goal is, again, we want to get the equation we're given in this form and then factor it and go from there. So notice how the slide I just came off of, a was 1. The coefficient in front of x squared was 1. So we're going to start off by first putting it in standard form and then getting a equal to 1. So I'm going to get it in standard form by adding 20k to both sides and subtracting 60 on both sides. Then I'm going to get a equal to 1 by dividing everything by 5. Alright, now that's not a perfect square trinomial because 15 is not half of 4 squared. So what we're going to do is just bring the 15 over to the other side, k squared plus 4k, and then leave a little space equals 15. And now we have to add a number to both sides that will make this a perfect square trinomial. And that number has to be half of 4, 2 squared. So you get 4. And then add it on the other side. Now you take this whole polynomial and factor it. And because it's a perfect square trinomial, it's going to factor nicely. K plus 2 squared. And that equals 19. Now, extract the root. Factor, or take the square root of both sides, and you get k plus 2 is equal to plus or minus root 19, and then subtract 2 on both sides. And you get k is equal to negative 2 plus or minus root 19, which means negative 2 plus root 19 or negative 2 minus root 19. So you can write it separately or write it like that. Alright, and that's completing the square. The last one is the quadratic formula. And I know you're dying to do this because you're a great math student. You're curious. You probably wonder where this formula comes from. Don't worry. We'll prove it in class. And if I don't, call me out on it. But I have it in my plans, so it should happen. But for now, you should memorize that formula. Memorization is like a scary word in teaching now. Like, you got to learn everything, blah, blah, blah. Yeah, I agree. You should know things conceptually. In life, you'll be able to look stuff up. But this you'll be used so much, it's worth just memorizing. And I remember having trouble memorizing it too, but you'll get the hang of it. Write it down a couple times, just use it every time you can, and you'll remember it. So there's probably a song or something to help you remember it you learned in middle school. Just remember it. So you got the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. We're literally taking the quadratic, putting it in this form, and plugging it. And I'll show you how to do that on your calculator in one step. So, let's do one. Ooh, almost forgot. Discriminant. When I use the word discriminant, I'm referring to the part under the radical. So we know that when you take the square root of a positive number, no issue. You usually get an irrational number. It could be an irrational number. It could be rational if the discriminant's a perfect square. But if it's positive, no matter whether it's a perfect square or not, since in the formula you're adding and subtracting it, you're going to get two solutions, right? And you could think of graphing both sides of this equation, this side being a parabola, this side being the x-axis, because it's y equal to 0, and when a parabola crosses a horizontal line, if it's below it facing up, it's going to hit it at 2 points. So you could think of those two graphs intersecting at 2 points. That's why it's possible to get two solutions. It's also possible to get one solution if you have that parabola and the vertex just happens to be right on the x-axis. Just hits it exactly at one point. Alright, and that's going to happen when the discriminant is 0, because now you're taking the square root of 0, which is 0, and adding and subtracting it to both sides of the equation. Which you add or subtract 0, you're going to get the same number, which is why you get one repeated solution, the same solution twice. And then, if the discriminant is negative, you'll have no real solutions, which just means, which means it's just never going to intersect the x-axis. It's either going to be always above it or always below it. And you can also think of it as if the discriminant's negative, now you're taking the square root of a negative, that's not a real number. Soon we'll learn how to express that in terms of I, an irrational number, but for now you just know if the discriminant's negative, the number under the radical, there's no x-intercepts, there's no real solutions. But there are imaginary solutions, but we're not going to worry about that right now. So, that'll be the next video. So, quadratic formula, first, got to put in standard form. So that's going to be 15a squared, and then add 7a to both sides, so you get a plus 4a, and then subtract 3, and it's equal to 0. Now we're going to plug that into our calculators. So, with our coefficients, a is going to be 15, b is going to be 4, and c is negative 3. And that's what we're plugging into our calculators. Boom. Yep, okay, so got to X out of the screen. 15, 4, negative 3 was A, B, and C. So now we're going to go to a new document and then add a calculator. So remember, the quadratic formula was all in a fraction. So I'm going to do control division. And I'm going to do the opposite of B. So if you remember, B was negative 4. Let me write this right here. A was 15. B was negative 4. No, B was positive 4. And C was negative 3. If you don't believe me, just scroll back in the video. But I'm pretty sure that was it. If not, we're just going with it. So starts off the opposite of B. So hit negative. I can't do that. Alright, I can't type if I have the words on the screen, so whatever. I'll just remember it. So the opposite of B. B was 4, so it's going to be the opposite of that, negative 4. Plus or minus. So for now, just do plus. The calculator can only do one thing at a time. Alright, and then divided by. So control division. Not division. Control x squared gives you the square root symbol. So now it's b squared. The opposite of b plus or minus the square root of b squared minus 4ac. So that's going to be open parentheses b, go to the side of it and then square it. Why are the parentheses important? They're not if b is positive, but if it's negative, you want to make sure you square the entire number. If you just type like negative 4 squared, then you're going to get a negative number. But after you square b, it should always be positive. So b squared minus 4 times a, which was 15, times c, which was negative 3, all over 2a. So all over 2 times a, which was 15. And then we get one solution. Boom. Nice. You get a nice fraction, a nice rational number. That's because 4 squared minus 4 times 15 minus 3, that's a perfect square. So now, let's do the other version of the solution. So what we're going to do is hit up, and then hit up again, and now that that's highlighted, you could hit enter, and it'll copy that. And you can edit it. If you just hit over to the right, now we just want to do the negative version. So now it's a delete, and then minus, and then enter, and then boom, there's your other solution. So they're not always going to come out this nice. A lot of times you'll get something like negative 3 plus root 7 over 5. That's totally normal. Sometimes you'll get imaginary solutions, and we'll see what that means next video. But you could always check it by graphing both sides and seeing where they intersect. But I'm sure you could do that on your own at this point. And if you need a quick reminder, just go menu, new document, add a graph, and then just type both sides in right here. Look for the intersection, and then use the intersection tool to find it. Alright, I'm not sure. Yep, that's the end of the slides, folks. It's been a pleasure teaching you math on this fine evening. I hope you find this video useful. And I'll see you in class, right? Have a good night.